Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Now, Andrew in Cambridge straight away has a question for you regarding jet engines on static test. Down the exhaust jet, there are luminous discs evenly spaced. What are they and how do they come about?
I'm not entirely sure what he means.
No idea.
I have a clue what it might be. The way a jet engine works, it's a similar principle to the car, but basically you suck air in at the front. And then you compress it. You put it through, basically you have a big spinning turbine and you have a load of vanes on that turbine. Basically big fans, and the air gets sucked in and deeper into the engine and compressed. And it gets to a nice high pressure. You inject fuel, you burn it, and then that gets very, very hot. When you heat up a gas, it expands. So it tries to expand a lot. It's easier for it to get out the back than the front, although there are turbine blades in the back. They're set at a much less steep angle, so it's much easier for the gas to escape out the back. Rushing out the back pushes, basically, the jet engine effectively is pushing the air backwards. So the air pushes the engine forwards and pushes the plane along. But in order to drive those compressor blades at the front, those compressor fans at the front, it needs to get energy from somewhere, and the way it does it, it has a load of blades at the back which kind of get blown around by all the air expanding outwards, and so you've got a whole set of a whole other fat set of fans at the back which basically work like a wind turbine. As all this air, hot air is rushing past, they get turned round, and then that turns the engine which runs the fans at the front. One thing the disc could be is these fans at the back. They're spinning at huge numbers, thousands and thousands of RPM, so they just look a blur. So you might be seeing red-hot blades spinning around incredibly fast. Those are one things which the set of concentric discs could be. Otherwise, basically everything in the back of an engine is going to be very, very hot, so it's going to be glowing red-hot. And so basically any circular thing inside the engine is going to look like a red-hot disc. And then with modern jet engines, the big fan you see at the front aren't these compression fans. The axle, which is being spun by all this hot air expanding, then basically drives a propeller on the front, which drags lots and lots of air around the outside and moves lots of air slowly, which is more efficient than moving a small amount of air fast. And so you'll see the sort of big outside part of the engine, and the inner bit will be very red hot with the concentric discs. But without seeing a picture, I can't be any more precise than that, I'm afraid.
All right, thank you, Angie. And thank you, Dr. Dave. Ralph in Stanford, Dr. Dave, says it's puzzled him over the last couple of days, having a chat on the phone, put it down, and 9 times out of 10 it'll ring again for no apparent reason, but no one is there. Why is this? That is a really spooky thing. I've had that happen to me before. What do you reckon?
Quite often the phone calls where you pick them up and there's nobody there are actually companies who are trying to sell things to you. Because what they do is because they want to keep the people who are doing the talking in the call centre busy all the time. They don't want them sitting around all that 10 seconds while they try and phone someone up and then they don't answer. So what they do instead is they get a computer to phone people up, and then phone lots of people up, and then as soon as they answer, they try and connect them to somebody who's an operator who's tries to sell you something. I know,
it's so irritating.
It's very irritating.
Particularly for elderly people who maybe have a trouble to get to the phone, and, then they worry.
Yeah,
it's wrong, should be stopped.
And then what happens is that they phone up too many people, they don't have anyone to answer it, and it goes quiet. It's not a nice practice, but it's probably what it is. Why it's always off. I mean, they're probably phoning you at times when they think you're likely to be in, which is probably when other people are phoning you as well.
And you can take yourself off registers like that, can't you, somewhere?
Yes.
I think you have to call up.
There is a register you can call which should stop all the reputable ones phoning you up.
Yeah, I think you have to ask your phone provider about that. Right, I hope that's answered your question, Ralph, and I know it is irritating, it really is. Mike in Colchester says, we know why we have a good good, healthy head of hair. But what's the point of underarm hair and pubic hair in the modern person? Why hasn't it gone during the process evolution? Now, Mike, what a great question, because Dave is you're quite a hairy person, aren't you?
I'm quite hairy.
I'm pleased to say I'm not, but where are you going with that one?
Yes, I mean, underarm hair, it does seem quite odd. I mean, the problem is evolution, it's not a perfect thing. It doesn't get rid of everything which is useless, and things don't actually have to have a purpose. They just have to help you reproduce or not be bad for you reproducing. So, I mean, it could be that it's useful for sort of basic evolution hasn't really been going very much in the last few thousand years because a lot of people have been surviving. It only acts very strongly when a lot of people are dying, because if lots of people are dying, then the only ones who survive are the ones with a certain set of features. If 90% of people are dying and then 10% with a certain set of features survive, then the population is going to change quite quickly. If most people are surviving, then then humans aren't going to change very quickly, or a species isn't going to change very quickly. Underarm hair. One theory of mine is that it might be quite useful for wicking sweat out and sort of lubricating your underarms a bit. Maybe if you're getting old or adult and sweaty, it sort of wicks the sweat out. Maybe it could also be good for wicking out sort of smells, because as you become...
There's nothing worse than a smelly man or woman, for that much.
Although apparently it depends on the smelly man. If it's the right smelly man, women can find it quite attractive. It's just all the ones who they don't find attractive. You see, it's a way of picking, because your body odour, it subconsciously tells
it's your
the opposite
scent.
Sex things about your immune system. And people have done some research to find out that people with different immune systems women find men with a different immune system their smell attractive. So the smell is telling you something about the immune system. And then if you breed with someone with a very different immune system, your children will be immune to lots more different things than each of you are individually. Whereas if you breed with someone who's got very similar immune system to you, they'll only be immune to the things which you're immune to. So some diseases are more likely to get bad diseases.
Aftershave sales have gone down now, Dave. You do realise that. Thank you. Now, Dr. Dave, Mick says, do you know about the Ares V super rocket being designed by NASA?
Yes.
Ooh.
This is one of the two new rockets which NASA is building now. The first one, they're basically to replace the space shuttle. They've sort of worked out that the space shuttle, if you send up the space shuttle and you're sort of lifting 100 tons of plane in order to lift into space in order to get 20 tons of stuff out the back of it. And so although it's reusable, the amount of energy it takes lifting the plane up and then bring it back down again is very inefficient. So what they're doing is they're going to replace the space shuttle with much more conventional rockets. There's the Ares 1, it's actually one of the solid fuel rocket boosters from the side of the space shuttle, with another rocket on the top and then some people on the top of that. So it's a bit like a giant firework rocket, which is a slightly scary concept. But the idea of that is basically make something quite very, very simple, which should be very reliable to get people up into space. And sort of maybe a few 2 or 3 tons of stuff up with them to keep them alive for a bit. And that will get people up to the International Space Station, but they're wanting to go back to the moon and build a base on the moon. Yeah. So to do that, you need to get a lot of stuff into space. So what they want to do is build a much, much bigger rocket, the Ares 5. This is sort of, if you imagine a space shuttle, it's sort of a longer version of the space shuttle tank with the 2 boosters on the side. Instead of having the rockets on the shuttle, they've just put the rockets on the bottom of the main tank. And this huge, great rocket, and then another stage on top of that, and that ought to be able to lift about 190 tons into low Earth orbit, which is a very, very large rocket, even bigger than Saturn V's. And then the idea is that you can then take lots of stuff to the moon using that. You send it up into orbit, then it meets up with the smaller rocket with astronauts in it. Then they sort of dock on and then get sent over to the moon, and then you land. So yes, a huge, great rocket. Then they'll actually end up building it. It's going to be a few years before it gets working. They're planning on 2019, but this sort of thing generally take longer than they plan because they suddenly turn out to be more expensive, and so it sort of slowly gets longer and longer. And whether it will survive the credit crunch, I don't know. But yes, that's basically what I know. With any luck, there'll be a base on Mars in sort of 10 or 15 years' time.
Wow.
But based on the Moon, Mars is probably a bigger challenge.
That's quite something, isn't it? I mean, God, absolutely cosmic. Now then, Gerald has sent an email in. He says, has the good Dr. Dave got any cool snow experiments to show off to the children? I've done the principles of movement with a sledge and how the tracks slide. I've also put 0.5 litre of hot water into a 5 litre empty bottle, emptied it quickly and put it on the snow to demonstrate expansion of gases and the effects of air pressure. Yasmin, who's age 12, comes up with some interesting questions, and after I explain the principles to her, she looks at me crossly and says, "You are doing it again. You're turning me into a fuzziest." How can you help, Gerald?
I'm not sure I can help with the fuzzyists. But one experiment which is quite nice is if it sort of explains why everyone's throwing salt on the road all the time. Is if you get some snow, put it in a container, get a thermometer, it'll probably be around about 0 degrees centigrade. If you then throw some salt in, what happens is that it forces the ice to melt. Yeah. But ice melting takes a large amount of energy because ice is a solid. It's locked together with lots of strong bonds, lots of strong hydrogen bonds. In order for it to melt, you've got to melt all these bonds, which takes a huge amount of energy. And so when you throw on the salt, it melts the ice, but that energy's got to come from somewhere. And where it comes from is by cooling down the ice and the water which you've produced. And so if you throw salt onto ice or snow, you can quite easily get the temperature down to -18, -20. And as an added thing, if you make some nice ice cream mix, so get some cream and something sweet. Cream and fruit is quite nice, sort of raspberries and things. You get some nice frozen raspberries.
Oh, yeah, sorbets, yeah.
Well, not sorbets, but you can get frozen raspberries and black... sort of blueberries and things, kind of nice frozen fruit. Warm that up, mix that in with some sugar, and then if you put that in a container, surround it by snow, a bit of that in the container, surround it by snow, throw some salt on the snow will get colder, down to maybe -18. That will freeze the cream and you get ice cream.
Wow.
That's how they used to make ice cream before they invented fridges. They'd get ice, add salt, which reduces the melting point, forces it to melt, sucks energy from everywhere it can see, sucks energy from your cream and your sugar, and it freezes and turns into ice cream.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Can you tell me if you can see the space shuttle docking on the International Space Station in the next few days as it launches today? That's from Mal in Norwich, Dave.
It will certainly be docking. You can see the space station with the naked eye as it passes over. But it's about 400 kilometres away, and it's a couple hundred metres across, so it's quite a big object. So, and in full sunlight, that reflects sunlight onto you, and you can see a bright object, but you can't see any detail with it. I know some amateur astronomers have got quite large telescopes, sort of 6-10-inch telescopes, and pointing those at the International Space Station and getting them to track it. And some of them have come up with pictures whereby you can see different bits of the space station, and you can even see the shuttle dock to it. But not without... So certainly it is possible to see it, but not without a fair amount of money spent on telescopes, or going to the NASA website, who I'm sure will have lots of nice videos of it docking.
Now, David in Norwich, he says, talking about jet engines, as we were a little while ago, if you're in space where there's no atmosphere, you use a jet engine to turn... How is this done, as there's nothing for it to thrust against?
OK, I think this is two different types of jets. A conventional jet engine sucks in air, burns it with fuel, and throw stuff out the back. It's called a jet engine because the jet effect is essentially if you throw something out of the back of the plane or your ship, you push it backwards. Newton's law says every reaction has an equal and opposite reaction, so every force has an equal and opposite force. So if you push the air out the back, it pushes you forwards. And so it's a jet. However, and a sort of a more simple jet is just squirt. If you're in space and you squirt something out of a jet or a thruster, basically you shoot. You've got high pressure gas inside your satellite or your spaceship. You squirt that high pressure gas out, so you're pushing it out one way. It pushes you back, and so it applies a force, and it will rotate your ship. So basically, it's not a conventional jet engine. It's essentially a rocket. Probably doesn't, but without burning anything, because they want them to be more reliable than that. So, I mean, it's using the jet effect, so they also call them jets.
Now, Dr. Dave, we were talking about, or you were talking out, you asked a question about armpits and bits and pieces like that, evolution. And then you were saying about that there'd been research gone into that.
Yeah.
And Jackie has said, and the Border Terriers who listen intently as well, how much research has gone into that one and how was the conclusion reached? Yes, I'm wondering about this, Jackie, aren't you? If a man smells right, then he's going to have a better immune system to breed with.
I think what they were doing was I don't know how big a group they were using, but what they did was they got lots of different men. They tested their immune systems, and they got a load of women and tested theirs by some blood tests. Chris would probably know better than me. Then they got the men to wear T-shirts, get them to do some exercise, so the T-shirts smelt of them, make them sweat a lot into the T-shirts. Then they gave all the T-shirts to all the women, sort of one at a time, and then got them to rate them as to how nice they smelt. Right. And they found that they'd picked the T-shirts from the men with a different immune system to their own, and they didn't like the ones with similar ones.
That's interesting. I wish I could have taken part in that experiment. Paul in Buckingham, he says, I understand adding salt to ice, the temperature will drop, but how did we make the ice if we didn't have mechanical refrigeration? He's thinking ice cream.
That's a very good question, and it's a very interesting story, actually. Basically, it came, because especially in the period we're talking about, 18th, 19th century, the climate was a bit colder than it is now. So all sorts of places used to freeze quite hard. So to start off with, in Italy and places, they'd just climb up the mountains, chop ice during the winter, bring it back down. They'd build a very insulated room. So you'd have a room with two walls with lots of straw in between the two walls. And just put lots of ice there, and if you get enough ice in one place, the amount of heat which can get in through all the straw is quite limited. And so it doesn't heat, so you don't lose all the ice until quite a long way into the summer. And so you can then make ice cream using the ice in the ice house. In a slightly later period in the 19th century, someone built a whole industry cutting ice in Canada, where you got frozen lakes, and putting it onto ships. And then taking it all the way around the world. They were shipping it to Britain, some of it they were even shipping to India.
Wow.
There was a guy who made an absolute fortune out of it. They called him the Ice King. And yeah, they were just chopping ice up out of frozen lakes and rivers, then putting it on insulated ships with lots of straw around them to keep it insulated and shipping it around the place. I think they were losing about sort of 2/3 of the ice by the time they got to India. But they reckon they could still make money, but the amount of money they could sell ice for in a really hot country like India was a fortune. So they still managed to make money out of it.
Wow. Martini, darling. Yes, I'll just get the ice from India. Mike in Colchester says a good tip to make a fast, cool wine, put salt into your wine cooler and it will drop the temperature quicker and cool your wine sooner.
Yep, you'll make the ice in the wine cooler much colder, so it'll suck the heat out of the wine much quicker. Bigger temperature difference, faster the heat will get out, so it will cool down quicker. Nice tip.
All right. Now, Tristan from Cantley has said, Dr. Dave does not seem to know much about jet engines. The luminous discs referred to are probably the standing shock waves you see when a jet engine is running on afterburner. Fuel is injected into the exhaust gas, giving more expansion and more power, but inefficiently. Secondly, jet engines do not push on the air. They eject air at high speed, giving an equal and opposite reaction. Stand on ice and throw a kilogram weight in one direction and you will slide the other. And then imagine your kilo weights are 1 cubic metre of air, weighing a kilogram, and you will have the principle of a jet engine or rocket. But rockets carry their inside. There's inside,
them,
rather than gathering it from ahead. Tristan, thank you very much. I think Christian needs to be a naked scientist, really. Also, Chris in snowy Bedford says the visible concentric discs that your earlier caller asked about are standing pressure waves called by residents in the engine's hot exhaust gas flow. Thank you very much, Chris and Tristan as well. Dave, are you happy with that?
Yeah, so you'll get some areas, so the gas coming out, the sort of waves going one way, they're getting reflected back again. In some areas you'll get an area of compression, it'll be slightly hotter and glow well. I'm glad to learn that.
Absolutely, well so am I, because I know nothing. We have a caller, I believe, on the phone, and we've got Ian in Stevenage. Hello, Ian.
Hello.
You're through to Dr. Dave.
Thank you very much. Yeah, I'd like to ask about GPS, or the satellites that I use for sat navs, which quite a few people have in their cars these days.
Yeah.
Is that one you're hot on?
I can do my best.
Okay. I believe they're in fairly low Earth orbit, unlike the Astra, and TV sort of satellites, which are 36,000 miles out. I'm just wondering if the orbit, because it's much lower, I don't quite know how low they are. I just wondered if the orbit would ever decay. Basically meaning they would eventually burn up in the atmosphere. And also the European Union is actually planning its own fleet of GPS-type satellites. Is it called Magellan, or I can't quite remember what the name is now.
Is it Galileo?
Yeah, one of those, anyway. Yeah, I think he's the bloke, yeah. That's the one. But I just wondered if what, if any, advantage the European system might have over the American military system, the GPS system we currently use.
So, yes, the satellites are in a fairly low Earth orbit, much lower than the geostationary ones, which are high up. I think it's relatively, sort of maybe 1,000 miles up or so. So not very, very low like the Iridium satellite, which just collided with a Russian satellite a couple of days ago. But fairly low. And so, yes, they will, because the atmosphere, although we say in space, where things like the space station are at about 400 kilometres, there's no atmosphere at all. There are still a few atoms floating around, very, very low pressures, and you will get some friction from that, especially if the sun's very active and heating up the outer atmosphere that expands, and then satellites slow down. So they will have a limited life. It's probably, at that sort of altitude, it's probably more limited by the length of time that the thrusters on the satellite have enough fuel, these little jets which keep the satellite in position.
Hydrazine.
Yeah, they quite often use hydrazine, which I think it's sort of so reactive that it breaks down. They heat it up and then it breaks down into hydrogen and nitrogen of its own accord. Or possibly hydrogen and ammonia. It breaks up of its own accord and produces a lot of extra thrust. And when that runs out, they need to keep doing that to keep them in the right position. And when you run out of the hydrazine to keep it in the right position, then they slowly move out of the right orbit. And you can't control them anymore. I think that's going to happen long before they start running out of energy due to friction at that altitude. I think Galileo satellites, which Europe are producing, I think they claim that they're going to be more accurate, or just because they're a slightly more modern technology. The Americans, of course, are going to then produce a GPS-2 or a slightly better version of their GPS. So the main advantage, I think, from the point of view of the Europeans, is that the Americans can't turn it off. Because the scary thing about GPS is that there's someone in America who has a big switch and can turn it off. And if you build all sorts of important infrastructure things completely dependent on GPS, like automatic, all sorts of, like the power grid is running off GPS time signals, lots of ships are being being docked by GPS because you can navigate within centimetres and sort of bring it right up to a dock very accurately. Planes are very dependent on it. more and more things are getting very dependent on GPS. I mean, we're slowly becoming more and more dependent on it, and either just there's a bug in their system and the whole thing goes down, or if the Americans for some reason hit the button and turn it off, then it's a very scary thing if your whole economy is dependent on this system, which someone has a switch to turn off. And I think fundamentally that's probably the reason why they're doing it, although they're saying it will be an improvement.
Thank you very much indeed.
Thank you very much.
Good to hear from you. Thank you.
Bye-bye.
Bye-bye. Jenna her daughter wants to know, why is it that snow is the white colour when you hold it, but when it melts, when it melts, it goes clear? Quickly?
And also big lumps of ice are clear.
Yes.
The reason is that ice is basically water. If you've ever looked at, if you put a spoon into a glass of water, it quite often looks bent.
Yep.
And there's two things. It looks bent because light, when it hits water, it slows down and refracts. You might remember this from school, and it goes around a corner.
Mm-hmm.
And so if you look through a glass of water, everything looks distorted behind it. So when light hits, all the little snow's made of lots of little tiny crystals. So whenever light hits one of the surfaces of these crystals at an angle, it's going to bend and sort of get sent off in a different direction. And also, if you shine light on a lump of water, you get a reflection as well. So some of the light, whenever it hits the surface of water or ice, some of it's going to bend, some of it's going to reflect. But all of that's going to end up going in a different direction to which it started. And if you've got one big crystal of ice, some of it bends, but it's a big crystal, so you only get one bend and one reflection. So you can ignore that, and you can still see a picture behind it, so it still looks clear. But if you have millions and millions and millions of little crystals that you get with snow, you get the light bounces and gets bent and then reflected and bent and reflected. So it all comes out in completely different directions. So although you're actually seeing lots and lots of little tiny distorted views of the world, they're so over on top of each other that all of the light adds up. You mix up, so all the colours which come into it gets mixed up. A mixture of all the colours it looks white, is white, so you see it as white.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.